One of the most common bending techniques in our process is hemming. In this video, I'll give you a thorough explanation of the hemming process. Let's jump right in. First, the flat pattern for hemming equals or time dimension. For example, in this drawing, the sheet thickness is 1.5 and the hem height is 20. The remaining dimension is 100, so the flat pattern is 20 plus 100 minus the K factor. The K factor equals 1.5 multiplied by 0.35, which gives 0.52. That gives us 20 plus 100 minus 0.52, which equals 119.48. How can I determine if my hem is accurate? Two methods. First, create a bend line first. The second method is bend to 90 degrees, then measure the 90 degrees dimension. How do we calculate the bend line? Let's see. What about our flip pattern? Equals the sum of two dimensions minus a K factor. Then the K factor equals half of the short leg dimension plus half of the long leg dimension. The bend line position equals the hem dimension minus half the K factor. Our hem dimension is 20. Then half the K factor equals 0.35 times the sheet thickness of 1. That gives 0.52, meaning half of it is 0.26. For a 1.5 millimeters thick sheet, the bend line position equals 20 minus 0.26, which equals 19.74. Then we convert it to a 90-degree bend since it's the easiest to measure. For example, the plate thickness shown here is 2.0. Our converted dimension is 20. The 90-degree dimension equals the dead edge dimension plus plate thickness minus the coefficient. Plate thickness. If the value is 2.0, then 20 plus 2.0 equals 22. Then subtract a coefficient from that 22. Coefficient is 0.35 times plate thickness equals 0.7. So the 90-degree dimension measures 21.3. A 2.0 plate bends at 90 degrees. When the measurement reaches 21.3, deepen the press at a shadow angle and flatten it. That gives us the 20 dimension and in actual practice. This method is very commonly used. Now let me demonstrate it practically so you can understand these formulas. The plate thickness is 1.5. That edge dimension is 20. For this scenario, our first step is to calculate the crease line position. After pressing one edge, we can observe this here. Our crease line exists. So this crease line, that's our hem edge measurement of 20 minus half the coefficient. If the coefficient is 0.52, then half of that coefficient is 0.26. So half of that coefficient is 0.26, therefore our crease position would be calculated as subtracting 0.26 from our hem edge of 20 leaves us with 19.74. Generally, measure crease with a just 0.1 millimeters, not major issue. Second step is folding to 90 degrees. The 90-degree bend dimension equals our hem edge of 20 plus the sheet thickness of 1.5. Then subtract the coefficient calculated as sheet thickness times 0.35. Adding 0.35 gives us exactly 20. Add 1.5 and subtract 0.52, resulting in 20.98, which we round to 21. Now it's 21.1. Assuming no issues, the hem that's folded should be 20.1. Insert the slight angle. The final cut flattens. .1